Hello students, welcome to the Madhav Institute of Technology and Science Electrical Engineering Department. Uh, so this is our electrical machines lab. This is a pic from the machines lab. Faculty in charge for this lab are Mr. Praveen Bansal sir and myself, Mr. Nipun Gupta. Along with us, we have our lab instructor, Mr. Rajesh Sharma. So coming to the list of experiments, in this session we are going to conduct electrical machine lab online. So these are the list of experiments which are to be performed for this semester. You can also find the list of experiment and the lab manual on my Moodle page. Okay, coming to the course outcomes, these are the course outcome for our lab. First one, demonstrate an understanding of fundamental control practices associated with AC machines such as starting, reversing, braking, plugging, etc. Okay, so you should be able to understand would demonstrate the understanding of the fundamental control practices that are associated with the AC machines. Secondly, you should be able to use the accepted national and international standards such as NEMA and IE code to select the appropriate electrical machine to meet this specified performance requirement, conduct testing and experimental procedures on different types of electric machines, develop the ability to work in a team and learn professional ethics, and you should be able to prepare an organized written report. Okay, coming to the objective of this experiment, today we are going to perform experiment number 1, that is to conduct no load and block rotor test on 3-phase squirrel cage induction motor and plot its performance curves. So these are the instruments that will be needed for our experiment. Number 1, voltmeter 0 to 500 volt 3 quantity, ammeter 0 to 20 ampere 3 quantity, rpm meter 2000 rpm range 1 quantity, and so on, like multifunction meter. We will discuss this instruments while we will be performing the experiment in the later part of the video. Okay, coming to the experimental setup, this is the experimental setup on which we are going to perform the experiment. So in this experimental setup, as you can see, these are the A1, V1, A2, V2 are the ammeter and voltmeter terminals. These are AC ammeter and voltmeter, as we are going to perform the experiment in for a AC 3-phase AC machine. So this panel we will also see in the later part of the video while we are performing the experiment, and we will make the connections as per our connection diagram in this panel and obtain the reading in the video. Okay, so coming to the statement of purpose, what is the purpose of this experiment? To obtain the variation of power and current both at no load and block rotor condition with the changes in applied voltage to the stator. So as we change the applied voltage to the stator, how the power and the current varies at both conditions, no load and the block rotor condition, that we are going to obtain the variation which we are getting, that we will obtain. And second one, we will be able to determine the equivalent circuit parameters of an induction motor. What are the circuit parameters that are required will be find out by conducting the no load and block rotor test of an induction motor. Coming to the theory, first we will discuss about the no load test, then we will go to the block rotor test. For no load test, we can say why the first question comes to our mind is why it is called no load test. Since this test is performed at the no load condition of the induction motor, that's why it is termed as no load test. And it is just similar to the open circuit test of the transformer. Just like we are performing the open circuit test on the transformer, just like that we can perform. Just like that we are performing the no load test on the transformer, and it is obtained as if you can recall, as in the transformer, open circuit test is performed to find the core losses. Here also no load test is performed to find the core losses, and the core losses are associated, as we all know, the core losses or the iron losses are associated with the shunt branch parameters. So it is so basically with the help of no load test we are finding the shunt branch parameters of the circuit. In this test, the motor is allowed to run with no load at the rated voltage. That is the main key point here. You should be able to that no load test is performed at the rated voltage condition. Let me switch to the pen view. Okay, so this thing you should also keep in mind, that the no load test is performed at the rated voltage condition. So and at the rated voltage, as we all know, the machine will rotate at the almost at a synchronous speed, as the slip is almost nearly equal to zero. Slip will never be equal to zero, as we have already discussed in the previous lectures. So here the slip will be almost equal to zero, nearly equal to zero, and you are applying that the rated voltage, so the speed will be near to the synchronous speed. So let's say we will the V naught, I naught are the no load voltage and the current, and phi naught is the power factor angle at the no load condition. The power consumed at the no load is equal to the iron losses or the copper loss. Sorry. So the power consumed at no load is equal to the iron losses or the copper iron losses of the open circuit losses. So the power consumed at no load is equal to the no load losses or the open circuit losses of the motor. So these are the readings which you are going to obtain from the no load test. We will discuss how we will perform the no load test, and with the help of the no load test, we're going to find these three reading: voltage at no load, current at no load condition, and the power at no load condition. And with the help of these three values, you are going to find out the impedance at no load, resistance, and the reactance at no load condition. How you are going to find out? We will see here. As we all know, impedance is equals to Z is equals to V by I. If we are talking about the no load, so we will talking about we'll take all the values at the no load condition. So why we are considering here is V by root 3 is here we are taking the line to line voltage, but for the phase value of the voltage we have to divide by root 3. So that's why we are dividing by the root 3. We all know that. Resistance we can find, as we all know, P is equals to I square into R at no load condition. So we can directly find the resistance from this formula, and impedance also and reactance also we are able to find out by the simple Z square is equals to R square plus XL square ka whole square formula. Okay, so now coming to the equivalent circuit diagram for the no load test, we will see here. This is the normal simplified normal equivalent circuit diagram of a three-phase induction motor referred to the primary side. Okay, so referred to the stator side, we can say primary side or the stator side. Okay, and this diagram will be converted to this one. How? As we are taking the slip value almost equal to 0, this term, this resistance will be almost equal to infinity. Okay, this term will become nearly equal to infinity, and as the resistance become infinity, it can be considered as open circuit. And once it is considered since it is open circuit, we can say that no current is flowing in this branch. And if no current is flowing in this branch, we can convert or simplify this circuit into this model. Okay, so here we have no load voltage R1, JX1, and only the magnetizing current which will be used for the magnetizing shunt branch. Okay, so what we have understood till now from the no load test is that we are taking the condition at no load condition, and we are applying the rated voltage here to the machine. And since there is no load present, the slip is almost equal to 0, and the resistance of the rotor is nearly equal to and this physical resistance is nearly equal to infinity. We can approximate the circuit into this form, and here only the current will be used for the magnetizing shunt branch, and since this is only used for the magnetizing shunt branch, current is only used, we can say the whole power which is used in the no load test will be used for our stator core losses only. Okay, so this is the connection diagram for performing no load and block rotor test on three-phase induction machine. Okay, so I'll explain this diagram in detail. Here we are getting three phases R, Y, and B. Okay, it is a three-phase supply, 415 volt AC supply. This is our supply terminals. We have mounted an MCB, and then we have also taken the fuse in the picture. Then we have taken the three-phase variac, or we can say that the three-phase auto transformer here. With the help of auto transformer, we can vary the voltage levels from 0 to 420 volts. Okay, so the rated voltage of the machine which we are going to perform this experiment is at nearly about we can say 414 volts at the three phase condition, 415 volt at the three phase condition. So why we are using these ammeters here in the line? So ammeter are used to measure the current in all the three lines, and the voltmeters are connected in parallel to voltage to measure the voltage between the lines. Okay, so generally we connect only one voltmeter across the lines. So because it is a balanced supply, so we'll get the same reading in all the three voltmeters. So generally generally in the connection we'll connect only one voltmeter and three ammeters in all the three lines. After that, this is multifunction meter. Multifunction meter will be used to measure the power and power factor of the machine at the no load condition. Okay, this circuit diagram or the connection diagram is valid for both your no load test and block rotor test. Multifunction meter will be used to find your no load power factor, no load power, so many things you can find out with the help of multifunction meter. But in this experiment, we will need only power and the power factor. And these are your stator terminals. These three are your these six are your stator terminal. Here in this diagram, these three connections are connected in delta fashion. While performing the experiment, it may be connected in delta, it may be connected in star also. Star connection, as we all know, like this. So this connection can be connected like this also. So here A2, B2, C2 will be shorted, and A1, B1 and C1 will be here. So these are the stator terminal which can be which are connected directly, and here is the rotor. I hope the connection diagram for performing the no load and block rotor test on three phase induction motor is clear to you. Next, coming to the procedure of the no load test, as I have already mentioned, here, we will first what we'll do. First, we'll switch on the MCB. Then we'll energize the panel by pushing the green button on the panel. Then we will ensure that the three phase variac is at 0 position. Okay, so once we have ensured that the three phase variac is at the 0 position, we will switch on the panel, and then we will gradually increase the voltage from 0 to the rated voltage for the no load test. For no load test, we will increase the voltage from 0 to 415 volts, and while increasing the voltage, when we will get the rated voltage, we will get some rated speed in the RPM meter in the panel, and we will take the readings of the at that condition. We will take the readings of the voltmeter, ammeter, voltmeter for voltage at no load, ammeter for current at no load, and multifunction meter for power and power factor at no load condition. Similarly, while doing the short circuit test, okay, we will come to the short circuit test or the block rotor test in few minutes. So after recording the reading, we will switch off the push button, switch the red button to turn off the panel, and MCB will be switched off. Okay, I hope the procedure is clear to you. Coming to the block rotor test. Block rotor test was similarly just like the no load test. Block rotor test is also similar to the short circuit test on the transformer. As we can see, it is performed to calculate the series parameters of the induction machine, that is its leakage impedance. Open circuit test is used to perform the shunt branch parameters, but the block rotor test is used to calculate the series branch parameters, that is its leakage impedances. Okay, so and how it is done, we will see with the help of the circuit diagram. The rotor is blocked to prevent the rotation, and the balanced voltage are applied to the stator at the voltage where the rated current is achieved. Now, here is the important point. The rotor is blocked to prevent the rotation. While performing the no load test, what we are doing is we are making the rotor free to rotate. We are not applying any mechanical load to the rotor. But while performing the block rotor test, we will mechanically block the rotor with the help of the pulleys. We will block the rotor. We will see in the experiment in the experiment in the later part of the video, and there you can see physically how we are blocking the rotor. And we will block the rotor, and by tightening the pulley, and by doing so, the rotor will be blocked and it will not be allowed to rotate. At that condition, the motor will draw very high current at a very low voltage. Even if you apply very low voltage, the current taken by the machine will be very large, because it will try to rotate the rotor, and while trying to rotate the rotor, it will draw more and more amount of current. As the rotor is blocked, it will not rotate. The motor will try to take more current from the supply. So what happens is, what we'll do in the block rotor test is, we will apply the rated voltage, rated current to the, we will apply the reduced voltage, so that the rated current will be flowed in the stator winding. You should note down here very carefully that the voltage should be increased up to the level in block rotor test, so that the current flowing in the winding reaches till the rated value. Okay, if you increase the voltage more than that, then it may damage the winding, because huge amount of current will be flown, as it is a short circuit, just like a short circuit condition, and it will be very harmful for our experiment, and the whole meters will be burnt. Under the reduced voltage and the rated current, core, and as we are operating at a very reduced voltage condition, what happens is, at this condition, the core loss and the magnetizing component of the current are very less, quite small. Why these are small? Because as we all have studied in the previous semester, core loss are dependent on what? Our core loss are dependent on our voltages. And as we are applying very reduced voltage here, magnetizing component of the current are also very small, so we can neglect it, है ना, in our circuit diagram. So slip क्या हो जाएगी? Slip क्या होगी हमारी वो मोटर की? Slip will be equal to 1. Why the slip will be equal to 1? Because the speed is 0, so the slip will be equal to 1. Equivalent circuit reduces to the form shown in the figure. Here it is the figure for the equivalent circuit. Since we are neglecting the shunt branch parameter, because of the reduced voltage, they have very little to the slight effect on the motor. So we will take only the series parameter, and once we will take the readings from the series parameter, we will be able to find out. We will take the readings in the similar fashion, and we will be able to find out the blocked rotor condition impedance, resistance, and reactance. All the things at blocked rotor condition using the same formulas. Okay, so how we are going to take the readings for the block rotor test? Procedure for the block rotor test is, we will discuss here. Here we will not apply the voltage from 0 to 450 volt. Rather, we will apply the voltage to 0 to some voltage until the rated current is obtained. Until the rated current is obtained. Okay, I hope this is clear to you. And once the rated current is obtained, you can take the reading from the ammeter and the voltmeter and the multifunction meter, and at that condition we will these readings will be called for the blocked rotor condition reading, and the rotor will be blocked at this particular condition. So this is the procedure for the block rotor test. This is the observation table which you will be able you should draw before going to the experimental panel. Everyone, draw this table on your notebook now. Everyone, draw the observation table and continue the video.
Yes, dear students, we have already taken the theory part of this particular experiment, no load and block rotor test, in our introductory part. In the second part of this experiment, we will learn about the procedure and then how to perform this particular experiment. So first of all, we explain the different parts, different apparatus used in this particular experiment. So we have this is the induction motor panels. This panels is basically designed for two types of motor, spiral gauge induction motor and slip ring induction motor. So this is the spiral gauge induction motor which fitted here on this platform, and this one is the slip ring induction motor in this platform. And connections have to taken on this board. See that this one is the spiral gauge induction motor. There are 6 terminals here. 6 terminals means by connecting these terminals you may connect in star or delta fashion. And this in this circuit diagram, this is the connections is connected in delta fashion. Similarly, this connection is given for the slip ring induction motor. So we have to perform no load and block rotor test on this spiral cage induction motor. So this is the panels. In these panels, the different ranges of ammeters and voltmeters are given here. MCB switch given here, and it's a circuit diagram is given here. This circuit diagram symbols for 3-phase varied. 3-phase varied instrument. This is the auto transformer or 3-phase varied, and this is the multifunction meter. Multifunction meter means why it is called multifunction means you can measure all the electrical quantity like current, voltage, power factor, power, reactive power, frequency, line to line voltage, everything you can measure with the help of this multifunction meter. That's why it is called multifunctions. So this is the RPM means spiral cage and slip ring. 2 RPM indicator are given here. It can measure the speed of spiral cage induction motor and it will measure the speed of slip ring induction motor. So first of all, we will try to connect the circuit as we have already told in the circuit diagram in our introductory part of this experiment. So this C1, this is the auto transformer, and we will take connecting leads here. So this is the input terminals. As you know, the input is the constant 415 volts, and this is the output terminals. This output terminals will connect. Output means variable. Variable outputs will connect according to this diagram. See that this is the auto transformer terminals. These terminals, there are 3 line terminals, 1, 2, 3. In these 3 lines, the 3 ammeter are connected in series, and this terminals is going to the 3 spiral cage induction motor. So first of all, we connect this portion of the circuit, and this one is the ammeter here in series like this. The main precautions while we connect the circuit, the connections must be tight for safety point of view. And second, ammeter connect here. Ammeter connect here, second terminals. And third, A3 terminals. A3 terminals. So these are connect series. The second part of ammeter, see that it is going to the rotor terminals, stator terminals. This is connected spiral cage induction motor in star connection. We will connect the star connection. You may also connect delta, but we will connect the star connection. How to connect the star connection? You know, in a star means similar points are connected either to starting or finishing. So see that this is the 6 terminals A1, B1, A1, A2, B1, B2, C1, C2. There are 6 terminals. Depending upon the connections, you may connect in star delta. So we are considering only star fashion. Clear? And how to connect in star? In a star fashion, so you have to create a neutral point or star point. In star points, see that this is the same connections here. So these are common points or neutral points like this. These terminals connect here and this one here. So it is the neutral point. neutral points. Okay, and now suppose you have to connect in delta. Delta is nothing, just to avoid terminal. Delta connection like this: A1, B1, B1, C2, and C1, A2. This is the delta connection. In the delta connections, you know, there is no neutral points. So you may connect in star delta, but in this experiment we are considering the star connections. And the star connections, we have to create a neutral point. Neutral point. The neutral points is a common terminals. So this is the star connection. Now, from this output terminals here, a multifunction meter is not connected here. But we can connect a multifunction meter. Then how to connect the multifunction meter? Multifunction meter means the output second terminals of a meter A2 terminals and A3 terminals. Actually, this multifunction is not showing in this diagram. You may connect the multifunction meter. Input terminals RYB, red, yellow, and blue. RY means red, yellow, blue. It's the symbols of phase sequence. Symbols of phase sequence. Connection should be tight. And this output terminals of this multifunction meter connect in the stator terminals of E1, and bias connect to B1 and P's connect to C. So a multifunction meter attached on those positions. The multifunction means it will measure the input, no load input power and no load power factor. And these are A1, A2, A3. These are connected in lines, so it will measure line current. And second thing, we have to connect a voltmeter here. So we voltmeter connect across two lines for measuring line to line voltage. Line to line voltage means you will connect in these positions. There are two lines, A1 and A2, V1. So we have to connect V1 terminals. In that case, we have to observe the readings of A1, A2, A3, A1, A2, A3 for determining the line current, and V1 voltmeter for measuring the voltage. So this is the complete circuits for performing the no load test. Second steps, after doing the connections, what we have to do, we will perform no load. No load means no any load is connected on this pulley. Means just this pulley we have to allow free to rotate. No any mechanical load is applying here. That's why it is called the no load position. No load condition, it means see that then zero positions means no any mechanical load is applied here, and it is called at no load position. Second, we have already studied in the theory part of this experiment. This test is performed at rated voltage. The rated voltage of this machine is 415 volts. And speed is rated speed 1500 RPM. So with the help of auto transformer, firstly you have to increase the voltage up to 450. Second thing, the main precautions, remember that while you perform this experiment, in any experiment, not like this, auto transformer should keep at zero position. It will keep at zero position. Otherwise, suppose it will like this here, and you will just start, and suppose the connection is wrong. In that case, the high voltage will go in this machine and all the meter voltmeter may be damaged. So this is the main precautions when you perform any experiment in electrical engineering with the help of auto transformer. This auto transformer is kept at zero positions. Now apply, taking the supply, switch on the MCB, and with the help of auto, gradually increase the voltage up to 415 volts. So we start the switch. So we start the switch, and deflections in given all the meter. In that case, we have to measure A1, A2, A3 and B1 and the multifunction meter. So gradually increase the voltage and see the deflection of V1 voltmeter. See that 38, 47. As we are increasing the voltage, the motor is moving. I think speed is in that conditions is speed is 370, so 500, and A1, A2, A3 indicates the line current. See that all the current are approximately equal. It means system is balanced. System is balanced, and this voltage value 238, 248, speed is increasing, 292, 315, 354, 380. Yes, this is the rated value, 410, 411. This is the rated value of this voltage. At this voltage, we will take the readings 0.9, 0.7, 0.7, and this is a multifunction meter. This multifunction meter measures the wattage. There are 3 wattage, and suppose you have to take its power factor. The power factor means with the watt, power factor is 0.19, 0.19, 0.3, it's the value of power factor. So we will take by the readings of power factor, power, line current, voltage. With the help of these readings, you may determine its performance of this spiral induction motor with the help of power subject test. So this is the no-load test, and this multifunction meter measures the power in each phase. 144, 19, 67, and by adding all these phase power, the power reading you will measure lower input power. So with the help of these readings, you will draw its power circle diagram. So this is the no-load test. Clear? Now, for doing the second test means like the block rotor test. In the block rotor test, firstly we will reduce the voltage. We will reduce the voltage and bring the auto transformer knob at 0 position, and the speed is gradually slow. See that the speed is decreasing because we have to reduce the voltage, and current is 0. Voltage also down. And the rotor eventually stops and then switch off. And wait up to for a stopping time of this motor, and then we will perform the second part of this test, block rotor test. So yes, the second part of this experiment, block rotor test. Block rotor test means head is clear from its null, rotor is blocked. Rotor is blocked means it will not rotate. You have to tie it with the help of this pulley. Then how to block it? With the help of this mechanical load, tighten the belt. Tightening the belt in such a way the rotor, this motor will not move. Tightly tight. See that it is not rotating. It means it is blocked. That's why it is called the block rotor test. Second thing, it is blocked, and its a load is here. See that it is not 0 positions. It is 22 kgf and 21. So it is totally blocked. Second thing, we have already learned in this theory part, this test is performed at the rated current. The rated current of this particular machine is 5 ampere. The 5 ampere is given its nameplate rating of this machine. The machine rating is 5 HP, 5 ampere and 450. This test is performed at the rated current. The rated current means with the help of auto, gradually increase the voltage up to 5 ampere current. The 5 ampere current is recorded from this A1, A2 and A3. So this is the conditions for block road test. With this test performed at the rated current. So no load test rated voltage and the block road test rated current. And supply on, switch on, and the process is the same, but the main provisions is that the current should not increase by this rated value, means up to 5 ampere. 5 ampere means readings 1.4, 1.9, 3.5. Yes, this is the rated current. 4.7, it's a rated current. 4.4, 4.4, and the short circuit voltage V1, V2, V1 only here, and it's a power. The power is high as compared to no load. 328, 302, 362. By adding all this power, we can calculate short circuit or block rotor test power. So this is the readings for block rotor test. It means in that test you have to set its rated current. In the no load test we have to set load current. By all these readings and for gradually reduce the current and up to 0 ampere. So this is the readings for block load test by and motor load is reducing. It is comes at 2 positions. Means it is free, and with the help of this short circuit current or block road current, power and voltage of this block road test and from no load test, we can measure its efficiency, its performance of the machine with the circuit diagram, and that calculation parts we will learn in the next part of this particular experiment. Thank you.
Hope you all have understood the experiment. So what is the conclusion from the experiment? Here you will write all the parameters which we have find in the which we have discussed in the earlier part of theory part of the video. You will take the readings and find the parameters and write down here. And you should also be able to answer these discussion questions. So note down these questions, and you should answer this question while writing the journal. Thank you, everyone.